Welcome, everybody. Thanks for joining us for the traditional Scala Days closing panel. It's actually more of a Q&A because we have nothing for you if you don't have anything. I mean, I can probably rant for a while, but I'd much rather take your questions. So I'm sure those of you who've attended before have your lists ready. I'm told there will be mics available. I can kind of see a couple of rows, and I think it'll be the same for the other people here. With the lights set up the way they are, we can't really see you. I'm assuming you can see us. Maybe we'll do a quick round of introductions before we get started, so you can, get your questions ready. So I'm Adriaan Moors. This is kind of like the hybrid pronunciation of the Dutch first name and English version of my last name. I've been working on Scala for about getting on to 10 years. Originally did the higher kind of types that you've all come to love, I'm sure. And yeah, I've been basically working on Scala since then, since 2007. For the last 3 years at TypeSafe Lightbend. And so I'll also introduce the people who aren't here today on the Scala team at Lightbend because it's kind of tricky for them to introduce themselves while not being here. So we have Jason Zog and Lucas Ritz, who both send their regards and their regrets. They will be in Berlin, but it was a little bit of a trek for them to make it here. I'll let the other members from the team at Lightbend introduce themselves later, but just want to make sure that their names were mentioned. So I kind of skipped Heather, but you're going to get a mic now, so you better be ready to introduce yourself.
Well, so as Adrian might have alluded, my name is Heather.
No,
my name is Heather Miller. I'm the executive director of the Scala Center at EPFL. I've not been hacking on Scala as long as Adrian has, but I was a PhD student under Martin at EPFL and then transitioned into this post very recently. So I think that's all I have to say. I guess I'm gonna skip Adrian now, since he already introduced himself, and we can go on to Seth.
Hi, my name is Seth Tishu. I am on the Scala team at Lightbend. I started there a little under a year ago. I've been doing Scala stuff since early 2008. Community meetups, conferences, a podcast, reporting a lot of bugs, a lot of different stuff.
I'm Bill Venners, and I'm from Artima, and I've been involved with Scala since 2000, you could say 6, so almost 10 years. I guess that is 10 years. But I'm not impressing you with my math ability. I do books on Scala and training. I teach it, so I've been involved a lot in trying to make it, explain it. And Scala tests, so I write a lot of code and sort of struggle with all the, have that kind of experience. I sort of do all different kinds of things, focus on Scala, and also do consulting and training. And they asked me to serve on the advisory board of the Scala Center. So I'm the community representative because I didn't actually fund anything. So I represent the people.
You get free coffee anyway.
Hi, I'm Stefan Zeiger. I'm the original creator of Scala Query, and which later became Slick. I've been working with Scala since 2007, 2008 or so, and I work for Lightbend since 2011. And since last October, I'm a member of the Scala team and now do mostly compiler work and related stuff like the SPT build for the compiler.
Hello, my name is Sebastian Duran, but if you pronounce it wrong, I won't be mad at you. So I started using Scala quite recently. I might be the youngest Scala user in this panel. I started using it in 2011, so only 5 years ago. And I'm the author of Scala.js and still the main project lead.
Hi everyone, my name is Eugene, and if we talk about who started using Scala latest of all, that'll probably be me, because I learned Scala while I was developing the Scala compiler, which is when I started my PhD program at the PFL. So among some less impressive facts, I actually introduced macros to Scala together with other guys from the Scala team, and currently I'm involved in the Scala Meta project, which is aiming to be the next Scala Reflect, the platform-independent meta-programming library that is enjoyable to use.
Do you have our first question, or should we start asking you things? I see a hand over there.
I'm not asking for like official opinion, just your estimates, your predictions about Dotty. Will it be called Scala 3.0 for marketing purposes?
All right.
Will it be even called Scala? What about like compatibility with older Scala libraries compiled for older Scala, or like people would have to upgrade their libraries, even Scala Z, and drop removed features and implement like all the magic using new features.
So
just estimates in your predictions. How you want that to look.
You've asked the question, which seems to be on everybody's minds.
Well, you know, it was on everybody. That was the first question last year too. Yeah, so I'm not going to answer time frame questions, but I will answer the evolution question. And the evolution started, you know, a while ago. So, for example, Scala 2.12, a lot of the work on figuring out how to encode traits and functions on Java 8 was done first in Dotty, and we took that work and well, by taking I mean stealing, and implemented it in Scala 2.12. So a lot of the progress that we were able to make quickly in the stable Scala 2 compiler was thanks to the incubation of those features in Dotty, and that's a pattern that we intend to keep repeating until Scala 2x and 3.0 become so close that it'll be a smooth transition. So these things, evolution necessarily, you know, takes effort on both ends, and our job as the Scala team at Lightbend now and since, you know, 2.10 basically has been, and maybe, you know, the observation is that we slow down Scala development, but I like to think about it more as smoothing it out and stabilizing it and making it so that it's predictable how much work it's going to be to upgrade to the next version of Scala that you're using, and to make sure that everybody is eager and able to be on the latest version of Scala. And so we've published our roadmap on Don Giovanni Part 1 and 2, and we've all spoken about that publicly, about, you know, what our plan is to take what Dotty is proving, or the proving ground that is Dotty, is supplying us with a lot of ideas for features and implementation techniques, speeding up the compiler. So the way I see it, and the way that I intend to approach this is to incorporate these features into the next versions of Scala. So concretely, in 2.13, we'll be working on modularizing, or we'll continue the work on modularizing the library. That has many reasons. So I mean, one of them, and that's been pretty nice to see in 2.11, is that the modules that started to lead their own lives and got their own repositories and their own CI and their own release process have also gotten their own maintainers from the community that are cutting releases and that are fixing bugs and that own a piece of Scala now. And that's something that I want to continue, and that's also part of the idea around the Scala core versus Scala platform discussions that you're seeing. You know, Scala is not just Lightbend, it's not just Scala Center, it's not just EPFL, it's all of us combined with the community in there as a player that we're hoping to enable, right? And so the modularization effort is an important part of that, and it helps in the evolution, it helps speed up things. It also helps in letting you stick with a certain version that works for you because you were relying on that bug or something like that, right? So that's part of that answer. Concretely, so in 2.13, some of the features that didn't make it in 2.12 was, for example, the better locking semantics for lazy vals that Dotty has now. that regrettably we didn't have time for in 2.12 because we are a small team. We're a dedicated, passionate team at Lightbend, but we are a small team. And that didn't make it in 2.12, but we really want to get that in 2.13. And there are other smaller things that we want to do to set the stage for Dotty, such as simpler things like procedure syntax, really pushing that deprecation through, requiring return types for implicits. Eventually in the 2 series, I hope to introduce trait parameters, get rid of early initializers, basically do all the small paper cut like differences with Dotty, get rid of those so that we can really focus on what the essence of the transition will be. And in the process, we've talked with the Scala Center about having something like Go Fix It or something like that, if you're familiar with that tool, which is kind of an automated refactoring tool, which will be a great fit for the work, on top of the work that Eugene is doing, to start evolving your code bases in a more mechanical way. For example, to get rid of procedure syntax, right, as a first simple proving mechanism for that tool. I think I've spoken quite long now. Happy to follow up questions or to have anyone on the panel kind of complete my answer or contradict my answer or refine it or whatever.
I would just say that I think everybody wants the same thing, and our culture is that we do want things to get better, not just stagnate. But we don't want it just to change. Someone didn't agree with that, what I said about that.
Keep the mic a little closer to you.
Okay. That's what the noise they make when you can't hear me. All right. I just didn't want to overpower everyone. The other thing I just wanted to say is I call it pin pricks, because paper cuts actually hurt.
I know, yeah.
So little changes that I can accept that when I upgrade. Okay, I have to fix that, and then I move on. But what happened that we want to avoid is the Python 3 thing where everything changes too much and no one upgrades, because it's not good for anybody. So that's what I think everybody is. I've never heard anybody who wants that.
We can do a show of hands. Does anybody no, I want Python 3? I have 1, 2. Dean, you're gonna be involved porting our code base. Well, yeah, about 5 hands. Okay, well, talk to me later. We have a job for you if you want to do some upgrading of code from 2.8 that we have lying around. Yes, John. Oh, there's a mic on the way.
Thank you. I have a question for Bill, and obviously you should never ask a question you don't already know the answer to. But Bill, what are you planning on doing as the community member on the Scala Center Advisory Board?
Yeah, I see my role as listening to the community and trying to collect input, and then communicating it to the Scala Center. So I just want to collect input. So please come and talk to me. You can email me, but I think I expect people will just, when they see me, they might say something. But actually, that's what I would like to do, is just hear what you want.
I can attest he's pretty friendly.
So that's all I know about my job, is that.
So what's the email address again? Because I saw it on this Gitter channel, but actually I think it's not been announced anywhere otherwise.
It's private-2-scala-center@artima.com, because it's basically, if you don't mind a discussion, just post to the Gitter channel, and then we can talk about it, and so can everybody else. If you want it to be private, I made an email address that it's private just to this. It's like private square bracket Scala Center that Scala Center people will hear about it, but you won't be in the public. Having said that.
We can repeat the question for you.
Yep.
Just speak up.
So what feature or features do you wish the JVM had that would let you do more interesting things with the Scala language?
So the question was, what features do we wish the JVM had that would allow more interesting things for Scala?
Tail calls. Someone's got to say it. But
We'll get them eventually.
JS has them.
I think that answers your question. What did we want? JavaScript. Yeah. When do we want it? Undefined or something like that. Yeah. So invoke dynamic is something. Oh shit, we already have that. Yeah, sorry. Yeah, class dynamic. Yeah. So something, specialization is something that I think we've learned over the years. Might be something that's more of a runtime concern, and by runtime I mean the JVM. Value types, so that's closely related to that. Arrays. Yeah, I mean they're really on top of it. Those guys at Oracle, like they're coming up with good stuff, and 212 it has a lot of uses for invoke dynamic, and whenever we talk to those guys at Oracle, they're happy to hear that statically typed languages are using them, because invoke dynamic sounds like it's something for JRuby or something, and that may be how it came to life originally. But we use it for anything from spinning up classes for lambdas when we need them to hash consing symbol instances. So like whenever you do apostrophe blah, that creates an instance of symbol in Scala that used to be cached in static fields and traits, and now that becomes a constant call site with an invoke dynamic. That's just one example, and that actually is exposed to you as macro. Oh wait, I'm not going to advertise. No, just kidding, Eugene. Yeah, so that's actually internally available to you at the invoke dynamic instruction. So you could write a macro, for example, to cache the regular expression matcher the first time that it's evaluated using the same mechanism. There's lots of other things that we're thinking of doing, like that haven't done them yet, but are thinking of doing. For example, structural types, invocations on structural types could be faster with invoke dynamic. I don't know. So I think the answer is actually not much. There's of course a lot of heritage there that we'd rather not support. Like everybody mentions overloading when those discussions are there, but I just don't see us being as successful as we are without JVM quirks and all. And JavaScript might prove us wrong on the client.
Well, some things are better in JavaScript, but some things are definitely worse. I mean, the question was not asked, but I'll answer it anyway. So,
please do.
So, from JavaScript perspective, the things I would like to see are first and foremost true longs. Because if you went to my talk, you may have learned that long operations are about 100 times slower than int operations. And that's because there is no long in JavaScript. So I really want that to happen at some point. Otherwise, again, there is not really much we would like from JavaScript as a language to improve Scala.js as such. It already has most of the things we actually want. And it's some things are closer between Scala and JavaScript than between Scala and the JVM. Some things, of course, are more different. So yeah, from JavaScript as such, not much. But then from WebAssembly, yeah, maybe, but that's maybe for another question.
Okay, now we're getting pretty far. As the moderator, I have to ask you to not talk about JavaScript frameworks and conventions. Okay, I was kidding. Sorry.
At the JVM Language Summit this summer, the dominant theme coming from the Oracle speakers was performance, particularly eliminating boxing and unboxing on primitive types. That seemed to be the main thing that they weren't just wishing for, but were actually going to make happen. Mm-hmm. And the designs that they presented seemed consistent with being able to take advantage of that from Scala. So they're already working on I think one of the things that most of us would wish for most.
Yeah. When I saw him in Philly last month, Brian said he thought we would be pleased, and I think we will be. But we've been pretty busy with 2.12 to really dig into what value types are going to bring us on I don't know, Java 8+N. All right, maybe the next question. Eugene. The mic's coming. You're very close.
Have to do a little bit of running.
So, what's your opinion on the standard versus non-standard, like let the community do its thing? Especially if JavaScript is coming along, really nicely, and there are certain things I think as Scala developer we already kind of like we ignore it, but like when you describe dates or something like that, you implicitly know like, okay, I have to now use Java's date, right? So, but I think there's a certain argument to be made that certain things should be just kind of be a community thing. So where do you stand, on JSON, IO, dates, that kind of stuff? Should they be a platform thing, or should we just let the community figure it out?
Did you say JSON?
Yes, JSON.
Seriously?
Yeah.
We talked about this before. I think I'm going to let Sebastian answer, or no? You don't have an answer? No? I saw you very eagerly go for the mic, but maybe that was my peripheral vision playing tricks on me. So, yes, platform. I really like the JVM, and I think of that as the Scala platform. And I know that Sebastian really likes JavaScript. I don't know. I mean, it's a tough question. I don't know how to.
Fortunately, we seated you guys at opposite ends of the table.
Yeah, that's just that's how we usually have dinner. I don't know. I mean, it's a tough one. I think it's dangerous to gloss over the differences between platforms, and I think some differences just aren't meant to be glossed over. You need to be aware of them, and you need to deal with them. I think it also comes back to kind of the discussions we had recently about unsigned. I don't know. Honestly, I don't know. The platform question is a tricky one.
Yeah, I guess one thing I would like to see from a Scala platform, Scala core differentiation is that at least the Scala core library would be completely portable.
Yeah. Okay. Yeah, I definitely agree with that.
And otherwise, I think it's a nice idea that we can modularize more, and some things will be JVM, some things will be cross-platform, some things will be JS only, some things will be native only. But the core, I think, eventually should be completely portable.
Yeah, fully agreed. I think can I move a little closer to Sebastian?
Yeah. So maybe I can ask a follow-up question to Sebastian. How portable is it at the moment? You must have first-hand experience with this. Like, how big of a pain was it to enable this for JavaScript, and how much actually works in JavaScript compared to the JVM?
More than you would think. For example, the entire collections API works, right? Because that's basically pure Scala code. Most of the things that rely somehow on the core aspects of the JDK work too, because we've ported the JDK, or at least a small part of it, but it's bigger than you think again, to Scala.js. So all the Java collections, for example, are there. So things that are not there are typically things that are inherently non-portable. So parallel collections, I mean, in case you don't know, JavaScript is single-threaded. So parallel collections just don't make sense. Other things like weak hash maps, that's not a thing in JavaScript. And no ES6 weak maps are not the same thing. So
what about reflection?
Next question.
Compile time reflection. That works. Runtime reflection is probably never going to happen for one good reason, is that it completely kills any kind of reachability analysis, which is a complicated word to say find the things that your code actually uses and put that in the JavaScript and not everything else. And that's really important, because if you don't have that for Scala.js, you have literally more than 10 megabytes of JavaScript just from the standard library. And that's not good. So you really don't want runtime reflection. you might have some controlled amount of runtime reflection, which is to say you say in advance, I want to be able to reflect by name the classes that extend that particular trait or class or something like that. And I want to be able to create instances of those classes via reflection. And that's something I've actually implemented as a sort of linker plugin. So it's an additional SBT plugin that you add, and then you can say, I want to be able to reflect class by name for those things and invoke those constructors and that kind of stuff. So you can do that if you control it. You're not allowing runtime reflection on the entire code base because that's not, I mean, it just doesn't work. But you can say, for these things, I really want it, and then you get it. There's a question in the middle there. The microphone is coming.
Is there convergence for the request for Strawman collection redesign? Or is that still too early?
Ongoing. But please send more designs. I mean, so we have stuff to compare and talk about, not because we don't like the existing ones.
There are a couple of Strawman proposals, and they are not actually all that different. So I think they go in the same kind of direction, just trying to simplify the current implementation, but it's still ongoing work.
Mm-hmm. Maybe I can answer a related question. Or if you want, you can ask it. And I mean, I can suggest you ask it and then we answer it. No, I mean, what we want to do to the collections is mostly internal. And as Martin said, regular users of the collections won't notice unless you've been doing crazy things like extending immutable collections or something like that. You won't notice, and that's why we've deprecated the non-finality of these classes, for example. So we've even though the exact design hasn't crystallized or converged, we have anticipated the changes that are going to be necessary or might be necessary. And so we've been trying to set the stage in 2.11 and 2.12 for those so we don't catch you by surprise. If you're just a regular user, I really don't want you to have to worry about anything. If you are implementing collections, you're going to have to pay attention to the process and you should participate if you're a big user of an extender of the collections.
Scala 2.12 is a compiler release. 2.13 will be a library release, and so that's things haven't converged yet. You shouldn't be too alarmed just because we've been doing compiler work instead. But that bit will flip over soon when work on 2.13 starts.
Daniel.
Hi, Adrian. It's my turn to heckle.
Hello.
Hi. This is maybe...
Can you co-heckle, please?
I will co-heckle because that's better than heckling. It generates an infinite amount of noise. So the question I have is actually kind of a continuation of this discussion. Could you sort of elaborate in general on what you see as like the path and the pace for deprecation and removal and changing of libraries? Because there's to set the stage, right, not just in collections, there's a lot of stuff in the standard library that, I mean, I think now that we understand the language better than we did 10 years ago, we know how to do it better. Mm-hmm. So how do we take steps forward in that? And what's the pacing? What does it look like?
Yeah, I mean, that's a great question, and I think it's one that we should answer in one of the kind of like the expert group that is the SIP/SLIB committee, but I can give you kind of a sense of what I think we should do. And I mean, when I talk about evolving Scala slowly in the Scala 2x series and what you've come to expect from upgrading from 2.10 to 11 to 12, that doesn't mean I want to stagnate, as we said already. And so some things that we've been thinking about is, for example, introducing deprecation during a cycle. So let's say in 2.12.1 or 2 time frame, it'll become clearer what we want for the collections in 2.13. We could deprecate more so that people get a heads up during 2.12 still, even though technically we only normally do that during 2.12.0 or 2.11.0 and so on. So to kind of reduce the lead time, because that's what we're all concerned with here, is like how quickly can we change the language? Does it have to be on an 18-month cycle? And I mean, we're definitely thinking about this, and maybe we should think out loud a little bit more. is how we can amortize some of that time, or how we can eat into some of that lead time. And so deprecating during a cycle is one of the ways that we've thought about. And for example, letting you configure how much of the deprecation you want to hear about during the error or warning reporting process. So for example, you could say any deprecation that was introduced in 2.12.0 is an error. Any deprecation that was later was a warning. Anything that was in 2.11.0, pretend it's not even there anymore. There's a whole spectrum that we've been talking about for a long time now about how the compiler could help you in migrating, and how it could help us or enable us to move a little bit faster in terms of changing the libraries. And so yes, there's a lot of cruft that we want to get rid of, and there's also a lot of users out there that we don't want to unnecessarily inconvenience, and it's finding that balance that is hard. I mean, we don't have the answers there, and we're definitely looking for feedback on how we're doing and how we could do better. And that's one of the key things that I'm excited that we have the Scala Center now to guide this process as an external party to our team at Lightbend that has we care a lot about the stability both for our enterprise users and the excitement of the community to introduce new features. But we're a small team, and we have a known bias that we favor stability, but we're definitely open in tweaking that balance and finding ways to evolve more quickly without breaking things. I mean, like, changes have to carry their own weight. I mean, I'm willing to break things and introduce new things if it's clear that on balance that will be a positive change, right? And I don't know how to measure that. So that's definitely something that, for example, the community build is instrumental in. We have 1.5 million lines of code in there, and if we can compile that saying, all deprecation warnings are now errors, let's see how we can get those out of there, then we can gain some more confidence that we can move more quickly. And we already have been using the community build to do trials like that, to run basically experiments like that. And I would love to do more of those. Yep. I have a question next to mine. Owen? It's the other way.
Speaking of that, SI 2712, will that ever make a 2.11.9?
I thought you said 2.9, but I missed the 11 in the middle there. Why would you want it in 2.9? Who's still using 2.9?
No.
2.11.9. Okay. I won't submit the pull request, but you can. We don't. So I mean, I'm happy to talk about this a little bit more. So I mean, first off, I want to say, Oh, sorry. So for context, it's that number that I refuse to memorize or recognize. But it's about, okay, so when we introduced type constructor polymorphism, the next question was, how do you generalize type inference to deal with now that there's type constructors that are expected for the arguments? And then the question becomes higher order unification, which, in fairness, this pull request makes a dent in, but it doesn't solve. So higher order unification is a very hard problem, and it basically, it's a very hard problem.
For people who haven't seen it, there's an open pull request against the 2.12 branch from Miles Sabin that has a proposed change to how Typer does this. That it's hard to say if it totally fixes the problem, but it certainly addresses
well, no, it's not hard to
many
say
of
that
the
it
use
doesn't.
cases.
I mean, I welcome the change, and I'm very excited that we're having this discussion, this pull request, and I'll be happy to merge this once we get all the feedback addressed. But so to answer your question first, which is, I'm sorry I didn't, it's an improvement to type inference, which in this area is a bit of a hack already. So we have certain kind of known orders in which type constructors are found and kind of like distilled from a long hierarchy and a long list of possibilities for how you could kind of single out a type. and it basically becomes a problem of program synthesis almost. Like since type constructors are functions over types, you're basically asking the question like, hey, I want a type of arity 2 that takes this and this to that. How could I possibly get there? So it's kind of similar to saying, well, I want to extract like a component from a tuple. Give me a function that does that. And in this case, as humans, it's clear that that's how you just call that method _2, and you get a function that does what you want it to do. On type constructors, that's it's possible to do like higher unification. Like if you go to languages that are built on unification, you get that. But I couldn't tell you how they do it, to be honest with you. I have never studied that in depth because it's a very complicated problem, especially since you have subtyping in Scala. I don't know how you would do it, like in a kind of a clean, principled way. But since it's already a big hack, we added another one, and it's not a bad hack. It's just a refinement of how we kind of run over all the possible solutions in a predictable way, or I mean, if you really worked hard on figuring out how to predict these things, but it is a predictable way to kind of single out type constructors as a candidate for type inference. And so Miles really went in and figured it out, and I'm thankful and I'm impressed that he did that. But I want to be clear that ticket, has been open for a long time because it's a really hard problem, and I don't think anybody knows how to solve it properly, fully. But that said, this is a nice enough way to add it to what we already have, and so yes, it might make its way into 2.11.9 if once it's in 2.12, and if someone wants to backport it. I don't think we've ever rejected a backport to older series, except if they broke binary compatibility or clear, requirements that we have for the 2.11 series. But I have no problem adding something under a flag there. If we didn't have a problem adding it under a flag in the later release. I have problems with adding things under flags in general, but that's another discussion.
So do you think that eventually this fix to 2712, it can make it into the official distribution without any flags? So what kind of...
we don't add things under flags if we don't intend that to be the case eventually.
So what kind of migration policy do you then envision for that fix?
The same as for other changes, we have to run experiments and convince ourselves that we can convince all people affected by it are willing to upgrade their code. My understanding is that this is not a change that is going to break a lot of code retroactively. There are some breakage that, and that's part of the ongoing discussion is Bill will have something to say about that. So, that's, I mean, the change is 5 lines, right? That's hard to do and hard to figure out, as we all know. Those lines don't just come to you, but that's not the hardest part in this case. And so figuring out a way to make this kind of to retrofit this on existing code. I'm always impressed when I think about single abstract method types, a beautiful way to retrofit function types on a language that didn't have them. But it bites you in all kinds of unpredictable ways. And we can talk about that in a different question, perhaps, if you wanted to ask that, hint, hint. But so figuring out all these interactions, getting all the involved parties on the pull request and figuring out how we can really set a path for everybody to evolve their code or to this new mechanism, that's going to take time. And so to answer Eugene's question, I don't know. But it really... The intention when we merge something under the experimental flag is that we think this is an acceptable change, and we want to find a way to making this an official thing. But before we do that, we need to get everyone on board and committed to upgrading so that we can all be in the latest version and we can all have our code keep compiling in some way.
So speaking of getting people on board, this obviously involves migrating the ecosystem, and eventually library authors start trying using this new feature and then publish these libraries, and then other library authors start depending on them, and so on and so forth.
Well, yeah, but I mean, so what I like about this change is that it's a local thing. It's not something that's viral. So it's not like when you compile under experimental now to get this fix for this bug number that I forgot again, but it doesn't require other people to compile under this flag, and that's one of the key requirements that I have. It shouldn't be a viral thing. Like, it shouldn't basically spread through the whole ecosystem. If you want to experiment with this and ultimately force other people to experiment with this so that their code will be compatible with it, and I want to yield to you, Bill, in a second. Shit, now I lost my train of thought. Maybe I'll yield to you now.
Okay. Yeah, I wasn't sure I was going to say anything because this is about me. I may be the only
Well, no, it's
person
not about
who,
you, but it's about your code.
Yeah, I may be
Which
the only
I
person.
agree is an important
I kind
distinction.
of I think I'm going to lose this.
Okay.
But what I think it's important to address a pain. There's a user pain for you have to use these type lambdas, and it'd be nice to get rid of them at least most of the time. And it does that, but it does it in a way that would want people to design a certain way that I wish we could find a way to address that pain, get rid of the type lambdas.
Mm-hmm. That was one of them.
That allows people to sort of pick. Well,
yeah.
I don't know how to say it, but just basically, it's like, you know, I would second what he says. It's not obvious how to solve it. This is one way to solve it. That it'd be nice if we could find some way that would work that you know, that would both solve the problem but not.
Yeah. I think we can conclude this because
I
do think that.
But that's what I.
I agree with you, and I mean, I think this is a topic that really affects a small minority of the Scala community. That I don't want to pretend like that isn't an esoteric thing to do. That doesn't mean it's a bad thing to do or that people shouldn't do it at all. But let's be honest here: not everybody needs higher order unification for type inference, or at least some approximation for it in their code base. And I got started with Scala because I was interested exactly in this, in data type generic programming, so what shapeless is now. And it's very impressive how far we've gotten in Scala in the last 10 years in enabling this kind of machinery and this kind of automation. But in general, I think one of the important things that is happening in the Scala community is finding a balance between what is available to us and what we're actually going to use. And that's part of everybody's responsibility in the community, and us as members of the designers and implementers of the languages, is telling people, like, look, abstractions are great, but they also need to carry their own weight. And losing some type precision for more understandable code, for more maintainable code, is sometimes a trade-off that is worth making. I mean, sometimes it's okay to have 2 lines of duplicated code if the abstraction is actually a really long other line that no one will understand later. And I think that's kind of a coming of age that I personally feel is important. I think it's easy to get very excited about all the new features and see where you can apply them, but then ultimately, what did that improve in your program? How did that make it more maintainable or more readable, or how did that really increase the expressivity of what you're trying to do? So, and I think we're kind of at the cusp here with stuff like this, with type constructor inference and shapeless in general, that it certainly has its use cases. But for example, in the compiler, we just hand code our boilerplate, right? We have our traversers that are just written by hand to reify the structure of our data types. And whenever the data types change, we rewrite those traversers, but I can tell you it doesn't happen very often. And that's one of the things that I didn't believe in when I started in Scala. I was like, must get rid of all boilerplate by any possible means. And I personally don't believe that anymore. I believe some boilerplate is just there because the cost to get rid of it is so high that I wouldn't recognize it anymore. And maybe that's like a meta point. But unfortunately, it looks like I'm already 2 minutes over time, and I made all kinds of promises that I was going to end on time, which now I have broken. I don't see anybody jumping up and down yet, so I also don't. Sorry?
As you find another question, can I just say one thing optimistic? I think there's a way to do it. And the one thing about the Scala is we innovate, we find ways to do things, and I think I just wanted to say something optimistic about it.
Yeah, no, I mean, I am optimistic about this. I think this is Absolutely, thank you, Bill. I mean, my nature of I'm from Belgium, and the weather always sucks there, and so it may you know, it may affect my how I come across sometimes. But I am very optimistic about this, and I think it's very important that we have these discussions. But I think, you know, that's a voice that isn't heard often enough, is saying like, look, you know, what does this abstraction give us? What does this craziness at the type level give us? Okay, sorry, not craziness. I meant in a general way. I meant, what does this, you know, complex machinery give us? And I say that very lovingly, having spent a lot of my time in grad school, during my postdoc and so on this stuff, right? I'm not saying this dismissively. I'm saying this, you know, as someone who cares a lot about this. And yeah, I think it's great that we have this discussion, and I would love to see more of those, both, you know, through channels like the Scala Center, like expert groups around at type level, at, you know, at the SIP/SLIP committee meetings. I mean, on the mailing lists, like when we discuss these things, first of all, you know, like I said before, you are not your code and you are not your abstractions, you are not your library. You're very proud of them, and you should be. But let's have a discussion that is, you know, more about the intrinsic merits of these things, and acknowledge that there are trade-offs here. And I mean that as a very positive thing, okay? And I think I have to wrap up now. So thank you all very much for coming. I hope you enjoyed it. I did. See you next time, perhaps in Berlin. Thanks.